I wish to thank the previous speaker for making all of the points that I was going to make, except more efficiently. So we can probably get through this pretty quickly. This is based on a talk from David Blank-Edelman. Are you in the audience, David? Upcoming book, Seeking SRE, which I heartily recommend you all go buy. It's a polemic. Anyone know what a polemic means? It's a rant, yes. It's a strong verbal or written attack, contentious rhetoric. So this is completely unlike how I normally do things, and I'm not very good at it, so this is going to be interesting. Okay, so on call. I originally came to the inspiration for this talk doing the research for my previous talk on diversity and inclusion in the SREcon just gone by in EMEA. So World War II, okay? The darkest moments of World War II, what we have is Colossus code-breaking machines in Bletchley Park. And something goes wrong. So what happens is they get a cryptographer called Irving Jack Good, I.G. Good, today known as the proposer of the technical singularity, if you can imagine that. And they wake him from his bed. So he's brought in, quotes, wearing a heavy overcoat with pajamas and dressing gown, quotes, to debug the problem. Okay, so quotes, his method of search was wholly abstract, conducted solely within an evolving mental model. Others streamed to and fro, bringing him answers to carefully posed questions, and setting out on missions to confirm or refute specific further instructions. As the logical map, invisible, of course, to the onlooker, shrunk to a single point. The problem duly found, Jack was conveyed back to his interrupted sleep. This is 1942, ladies and gentlemen, plus or minus a bit. Now, I read that and I say to myself, you know, actually, that's pretty interesting because that is a one-to-one correspondence with the thing that I do, or the thing that I used to do when I got paged out of bed. And it's still completely recognizable from 1942. Okay, so surely we must have had, as a species, some improvements over the 75-ish years since that, so that people don't have to get woken up, do various tree traversal mechanisms in their head, and try to pinpoint a solution in their pajamas. Or is the major contribution of science to the development of the field of on-call the creation of central heating? So at least we don't have to wear a heavy overcoat or a dressing gown while we're doing this. No, ladies and gentlemen, I think we all know that us in the room who do on-call, as a professional practice, whatever job title we have, I think we know that the baseline of on-call is actually frighteningly unaware of essentially any development since 1942. The baseline, mind you, I say that carefully because you might happen to be on a team where things are better because you're working at it harder, that's fine, accidentally maybe. But the default for the industry, I would submit, is still very much a person, a pajamas, and a problem. Like, that's what it is. So quite frankly, that's not good enough. As an industry, we have piecemeal approaches here and there to this, and we need a systemic approach to make it better. We need to change it, and that's what the talk is arguing for. But let's ask an always important question. If the clicker works, which the clicker does not work, excellent. Yeah, go for it. Oh, it got there in the end. Okay, excellent. So, why is a great question. Whoops. And now we need to go back. Even one. Yes, excellent. Do you want to do the back and forth, or will we give it another go there? Yes. Okay, that worked a little bit. Let's see if we can do better now. Okay, on-call. Why does on-call exist in the first place? On-call exists to resolve AV problems. Two questions, actually. Why does on-call exist in the first place, and what are the impediments to actually changing it? How could we work around those impediments? The question of why on-call in the first place is interesting. I guess we have some intuition about it in the audience. Stuff goes wrong, we have a human to fix the stuff. Okay, that's fine. I am going to claim that it's useful to look at how we do this in other industries so that we can support or undermine this intuition in some way. So I'm going to talk about medicine in this case. And now I'm not going to talk about medicine. Oh, I am going to talk about medicine. Yes, excellent. We got there in the end. Okay, why medicine? Because there's emergency medicine. Okay, so this thing called the ER, A&E, accident and emergency, and so on. People are on call in these circumstances. What does it mean in medicine? Here, the person on call is on duty. They are ready to respond. So in emergency medicine, it's very interesting. The function of the doctor is to be, in some sense, a portable decision maker. Okay, so with appropriate expertise or the ability to call on the appropriate expertise as required. First function of an emergency doctor is to perform triage, where the doctor figures out from the signals available what kind of treatment is appropriate and whether they go in this particular ward or this other particular ward, et cetera, et cetera. So, yes, the job of emergency medicine is to try to make the patient better, but it's not necessarily to cure them. Not in emergency medicine. The task of emergency medicine is to stabilize the situation so you can stick them in ward medicine. And ward medicine is where you work with the treatment of conditions when you no longer have an emergency, which is a problem for the patient. You're managing slow decline, like my life and so on. Or otherwise handle non-life-threatening emergency situations, or non-immediate situations. So there's some obvious parallels and some differences. So emergency medicine is obviously fairly strongly interrupt-driven work. Okay, fine. And broadly, bringing people with expertise to fix a problem is the same as the SRE on-call context, right? Another parallel is the act of triage, where I guess in the SRE case, we're relying on software to kind of realize that something's wrong and page us. Sometimes it's humans as well, of course, but we don't really like that bit. There's another parallel, actually, which we'll explore in more detail in a moment, but we'll touch on it if this thing will go to the next slide. 2, 3, oh yes, here we go again. Excellent. Okay, so interesting point. If you read that book, which, ladies and gentlemen, for the purposes of making the most optimal presentation, I'm pleased to tell you I spent 50 quid on and read. Anyway, or whatever it is, preparations for an on-call shift in the medical case are actually extremely similar to the SRE case. So you've got recommendations for stockpiling food that will get you through the 24-hour on-call shift and so on. But you also, interestingly, have on-call playbooks for emergency medicine. And the on-call playbooks are essentially, here are a list of special case things that we know go wrong with the specific subsystems in the human. Hey, if it's an autonomic problem, it's probably this. Or if it's a heart problem, it's probably this, et cetera, et cetera. There's a strong presumption that a kind of a Pareto principle 80-20 rule arises, that 80% of the stuff you see is kind of resulting from 20% of the causes, possible causes, and so on. And also, the presumption that emergency medicine leads to ward medicine if you're doing it correctly. Okay, so. Now, did we go too far? I think we went too far. Skip one. Go back, please. Nope. Okay, can you go back one? And again? Yeah, not working. Oh, maybe I should stand closer. Do you think if I stand like that, that'll work? Okay. So the largest difference, ladies and gentlemen, between emergency medicine and working with humans and working with software. What is that? Software is fundamentally different, right? Software is fundamentally different to working with humans. So the frightening thing about being SRE on call is that being on call for the same system in January and being on call for it in June, like those are potentially very different experiences, right? It's almost as if you're in the emergency room, you get new kinds of humans in the door every day with previously unexplored and unencountered organs for which the documentation has not yet been written. Having said that, yes, there are humans who have duplicate organs and so. Okay, fine. But like broadly speaking, the fact that software can change all of the time and does, because we're chasing product market fit, is really important, a really important distinction. And that unbounded quality is really where we're coming from when we say there's a problem. Yes, excellent, okay. I will now go over to the other side of the stage every time I press a key. So with the medical context in mind, let's go back to the questions of why. Like, why do we put people on call at all? So by analogy with medicine, medicine puts people with the expertise in the position to make the decision and resolve the problem. Today, we put humans in those positions in the SRE context. Today we put humans in those positions in the medical context because the complexity of the world is such that no robot that we know how to program today would be able to solve everything. However, I argue that the highly restricted environment inside data centers, clusters, etc., is not equivalent to the complexity of the real world. And so we don't actually need to have the humans in place, really. And we'll discuss more about that in a second. But we do still continue today to put engineers on call for services. And why is that? Well, let me be brutally frank, fellow operations engineers. We are sometimes put on call for bad reasons, okay? Anyone have a problem with that assertion? I could skip the slide, maybe. So one well-known bad reason for putting us on call is that because it's cheaper than solving the real problem, okay? So you could get the product development people to resolve the problem in some way and push out the software and so on and so forth, but we don't. We pay for folks to answer the pages for things which are already known about and the resolution is known, etc. So what we're doing essentially in that case is business owners are paying for the code of the resolution, the problem resolution procedure, to run in the brains of the humans rather than the CPUs of the machines. And in some cases, that's cheaper. Well, who knew? Another bad reason was because on-call work is perceived to be awful, and therefore product engineers don't want to do it. And so they push that task on to a lower caste. Operations engineers. I know, I feel your pain. But another, more critical assumption, cultural assumption actually, is that mission criticality, for some definition of, a kind of a keep the site up style mentality, and a sense of urgency all require being on call. You need to be on call for these. But in fact, I would challenge anyone in the audience right now to put a number on precisely how much being on call helps those things. Like, what's the relationship between all of those things? I'm not sure there is one. I think this might be way more like dogma, possibly even unexamined dogma, best kind. Do you actually need on call to service mission criticality? Or is it a distraction? Do you need on call to be oriented around keeping the site up? Or is it a distraction? Could, for example, design contributions at the design phase of the SDLC contribute more to the stability of your product than waiting for the problem to happen and fixing it there and then? Like, maybe that's cheaper. Well, actually, we know it's cheaper. After all, by the time an on-call page has happened, it's often too late to keep the site up, depending on how your monitoring architecture works, of course. Way, okay. Yes, excellent. So another reason why we're still on call, like maybe it's us. Ever think about that? Ever think how we contribute to our own problems? Since I'm keeping on making friends with this audience, I'll I will elaborate a little bit. If SRE is about keep the site up and that kind of strong mission-driven mentality, let's say it partially is for the moment, we attract those people, that situation attracts those people, and they're motivated by it, they're comfortable working within that kind of environment. So SRE often finds that set of people who like to step up and resolve production incidents and work hard at fixing things. Yeah, cool, we're mission-oriented, we get the job done, keep the site up, et cetera, et cetera. But we also ram our heads repeatedly against production problems. Like, that's what happens in the industry as a whole. And I guess it's sometimes admirable to do this, but mostly it's admirable in bad. Like sometimes you get the system fixed via a bad, unsustainable way. Doing that has at least as many drawbacks as it does benefits. How can a hero be wrong? Like, we had a bunch of discussion about this in the previous talk. There's also Emily Groszinski's talk in the previous SREcon. Or you continue to sit in your chair for a bit while I lecture at you why it is wrong. There are many negative consequences of heroism. Being the hero usually gets you some kind of approval. There's some kind of feedback loop. Then people come to expect it. Management are all like, hey, you threw yourself on the grenade the last time. You got a couple of limbs left. Throw yourself on the grenade the second time. And your peers come to expect it. Hey, they were really great when they resolved that thing the last time. And I'm kind of busy. Would you be really great again this time? And so on. So there are also subtler ones, because when a heroine steps up and fills a particular role, there's work that's not getting done that should be done. And so you're spending time on reacting rather than proactively fixing the future. So Alice Goldfuss has a talk about this in her 2017 Monitorama. And also Tanya Riley had a recent talk about being glue in a team and getting people to agree on what to do and career development-related stuff. And the interaction between career development and on-call in this profession, like, it's actually kind of really, really bad. So bluntly, the profession takes on-call very seriously and tries to be good at it. Yep. Yet it's very, very rare for this to be rewarded in any meaningful way. In 11 years at my previous employer, I never saw anyone get promoted for on-call performance. Not once. 11 years. I saw a bunch of people who didn't get promoted because they were bad at it. Oh, that's fine. Like, that's obviously some gap. But clearly, this will not get you the career recognition that you deserve. And also, weakness. So on-call is tough for reasons we'll go into and talk about later on. Possibly even worse than all of the above things I've said is that in some ways in the industry, it's kind of a sign of weakness if you can't do on-call. Like, if you're connected, if I suspect this is connected to our unwillingness to think about alternatives to kind of emergency medicine on-call. And a number of people leave the profession in order to avoid on-call because they've no alternative. Like, they're caregivers in some sense, and they actually can't do the on-call bit because on-call and the profession are seen to be so tightly conjoined. Whoa, 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 whoa. This clicker is awesome. Okay, we're good. Right, so, risk management. So, enough about the humans for a moment. Well, okay, not enough about the humans. We'll have more humans in a moment. But how does the business look at this? What is the business saying when it's putting people on call? Like, why would it do this? Okay, so, all right, you think you'll have a problem with the system at some point, so you put somebody on call for it, fine. But, like any problem and the solution that you propose for this problem, it'd be good to actually check if that's an effective match between what you think's going wrong and what's actually going wrong, yeah? There is detail here. So, for example, what kinds of problems do we tend to get called for? What kinds of problems really require emergency medicine with the full human right there and then, and what kinds don't? Maybe it's a subset of the total problems that we get called for. So we certainly can't divide the problem space by specifics or we'll never get anywhere. So in the talk, I'm going to, by fiat, declare we'll use the language of risk management to do this. So if anyone remembers Donald Rumsfeld, hooray, I got the Gartner quadrant for you. So a typical classification of risks is the following. Based on level of knowledge about a risk, i.e. the risk of its occurrence, known or unknown, and the level of knowledge about its impact, either known or unknown. So you get this known knowns and famously Donald Rumsfeld unknown unknowns. It's actually a completely legitimate way of understanding what's happening in engineering systems. So cutting to the chase, it seems clear to me that most of the opposition to removing on-call, emergency medicine on-call, is because of unknown unknowns. Known knowns, known unknowns, unknown knowns, and so on, all have very many useful things which can be done about them that don't have to take place within the context of emergency medicine. So unknown unknowns, we are facing something that's never happened before and that could have a gigantic impact, which motivates most, I claim, business owners to put folks on call for systems. So let's go through some of these. Yes. Okay, first one, known knowns. So, people in the audience, you have probably been paged for something that you know what the problem is, you know what the remediation is, you execute the remediation, and you go back to sleep, right? Yes? Yes. Why did that happen, ladies and gentlemen? Because it's absolutely useless that that happened and that it was a human doing that. All of those components in that chain were well understood beforehand. The only reasons are money and time. Money is a useless reason. Time, you just wait and there's a bit more time. See, there was a bit more time there and there and so on. Well, anyway, okay. We have a system with known bugs. We have a system with a known remediation which works totally well. So why are humans fixing this at all? It's because the business owners are paying to run the code inside the brains rather than the CPUs. So this is about expediency. This is about cost control. This is not a fundamental computer science reason why we can't actually handle this in any way. I suppose you could call it externalizing your call stack with a vengeance. Cool. All right there, Liz? All good. So, known unknowns and unknown knowns. So, known unknowns are a bit like Christmas. You know it's going to happen. You know when it's going to happen. You know it's going to cause some kind of a drop-off, say if you have a web service you're running, etc. Not necessarily how much that drop-off is. Unknown knowns is a bit more like a social media influencer, like linking to your blog. You can't necessarily predict this is going to happen in advance, but you do know it'll bring a lot of hipsters with them. Now, failures like this kind of thing are because of external action or maybe some interaction of some kind. So you've got change management, excessive resource usage, quota limits, access control restrictions. All of these might end up tripping you in some way. Even though after you get a bit of experience under your belt, you realize that this kind of thing does tend to happen periodically and that there are actual automatic ways of addressing them as well. So in this bucket, really, engineers are on call because the automation to do the auto-scaling or the partitioning or the canarying or whatever it is either not available or hasn't been rolled out yet. So there is, again, no computer science reason why we can't address these problems. We can get more resources. We can pause normal processing in some controlled way. It's all about controlled failure, partition failure. Even application layer problems like queries of death and so on, all of those are actually handleable as long as you've written your code correctly. Big caveat. So a huge technique we can use for kind of self-inflicted problems, particularly on systems, rollout levels and so on, is canarying, allowing us to pilot a variety of changes within a small environment so we can see the problems and then roll it out over time. But instead of paying for canary environments, again, we typically pay for the humans to do this. And we typically pay for the humans to make the change and watch the process, perhaps reasoning that if we have to have the humans around for unknown unknowns anyway, they might as well handle all the other stuff as well. But actually, there's a huge difference between these categories. So, yay, that worked. Unknown unknowns. So it really does come down to, I think, at the business owner level or at the computer science level, the question of unknown unknowns, things that just, you didn't know they were coming, you didn't know that interaction was possible, it balloons out of control, and all of a sudden you have an incident. What are the lurking, unanticipatable problems in your code base? Well, actually, by definition, you can't anticipate them, so you can't address this. And we've all been on call when fairly arbitrary problems of arbitrary depth have cropped up. And so it seems natural that we need a human around in order to be able to encompass the total interactions of the system and make the remediation. But actually, let's turn that intuition around a little bit and say that we don't need to have a solution for every possible problem in advance, like maybe that's halting problem equivalent or something like that. But instead, what we need to do is to translate problematic states of the system requiring emergency medicine into ones requiring business hours intervention. So it's ward medicine without human intervention. So there's a very big difference between solving the general case of all unanticipatable problems, which, spoiler alert, you can't, or the specific case of constructing software to be way more resilient to unexpected problems within their specific domains, which actually you can. Now, it is absolutely true that there have been many delicate effects, many sizable incidents where delicate effects have had a role to play. But again, there's detail here. Where do these delicate effects come from? Like, what's the origin of the complex interactions that we see? What are the contributing factors? And so, in my opinion, it's kind of basically the state of the industry itself, right? In general, we're not building reliable systems, not because we're not trying to in some sense. There are well-known building blocks out there that we can assemble, but they're not programmed to fail in well-understood ways in known environments, cloud providers, etc. We're not really doing resilience engineering. We're doing kind of building block engineering. The reality today is that most of the state of the art is the most successful application layers, whether they're for startups or for huge multinationals, are reinvented time and time again from the ground up. So this leads to a situation where we do stick the building blocks together, typically in some kind of microservices architecture, but each enterprise kind of does it from first principles from every time. So it's as if the construction industry derived bricks from first principles every time. And the only reason that houses in a row shared bricks was because the teams sat to each other next at lunch. And so the teams were saying, oh, we learned how to make bricks this way, and so on. And knowledge transfers that way. So to put it another way, part of the reason we see unknown unknowns having bad effects on systems in the first place is because the fine detail in how these things interact is not well understood. And the reason they're not well understood is because people write them from the ground up time and time again. If we had a consolidated set of software components which behaved in well-understood ways, in well-understood environments, we could offset these risks significantly, perhaps even entirely, depending on the domain. Or, putting it in the language of solutions rather than problems, we need a safe cloud stack, or at least cloud components that behave in safe ways. Oops, yay, we can go back. Excellent. Of course, maybe you want to go on call for this phrase which was introduced in the DevOps and SRE article in the SRE workbook, the wisdom of production, which is you want to go on call because you want to find out at the sharp end how your system behaves. That's fine, you can go do that. That's totally okay. But actually, maybe we don't need to do it in emergency medicine conditions. Now, Yes. Do I need to go closer? I do. Counter-arguments. Okay. You all probably have a bajillion counter-arguments in your mind right now. This will never work. You're an idiot, et cetera, et cetera. An important counter-argument is that all the above observations are all very well, but here in the real universe, with bespoke software everywhere and limited budgets and time and so on, there's no prospect of avoiding unknown unknowns, and therefore we're still locked into doing this for the indefinite future forever. Well, this may well be true in the sense that there is a finite amount of money around, or maybe we can create that electronically now, I don't know. Somebody told me that the other day. But almost every piece of software does go through a rewrite cycle at some point, particularly things in the modern world, on the bleeding edge, etc. We can use that rewrite cycle to pivot our concerns more towards resilience engineering. Another counter-argument for going off-call is that this will prevent on-call engineers from understanding and effectively troubleshooting incidents if they're removed from how the production situation works. We should totally continue to do on-call throughout the industry, although maybe not in the emergency medicine context, maybe during business hours, et cetera, et cetera. And so, if the objection is to the idea of an industry population of SREs that's increasingly feeble at on-call, if we move away from emergency medicine and towards ward medicine, where observation over time is possible, where support from your colleagues over time is possible, where you have way more resources and way fewer pajamas, hopefully, that's actually a much better situation for the industry as a whole, because the problems will get resolved sooner because there are more resources to bring to bear upon those problems. Finally, some people say, don't mind that, machine learning is going to fix it first. Laughter from the crowd. Okay, so some folks say machine learning may be an effective substitute for human on-call. I'm more skeptical. I think it might help. But I don't think that post-event diagnosis and remediation, aided by machine learning, is actually more effective than contributions at the design stage of the SDLC. I don't want a more effective whack-a-mole machine. I want the moles not to have to be whacked in the first place. Okay. That worked? How are we doing for time? Okay, not that much. So, I'll summarize. Spoiler alert, humans aren't very good at stress. Any problems? Okay, fine. There are loads of statistics and loads of papers showing this. The most generic studies on human error seem to arrive at a background error rate of about 0.5%. And then if you're doing stress, those rates rise sharply. For example, there's a Microsoft paper which shows that middle-rank chess players double their chance of making some stupid error as the time available to make their move drops from 10 seconds to 0 seconds. So as the stress and pressure of your situation increases, your chance of making an error also increases. I am not sure that we really need to go into a lot of detail to prove that this is true. Presuming this is true, and maybe most of the above merely supports, as I'm saying, what you already knew about the human condition. There is a subtler effect as well, though, which is that the fear of doing on-call is often enough by itself to radically change people's behavior. So entire development teams reject outright the notion of going on-call because they're so scared of it. And many such teams are, on the other hand, perfectly happy for the operations teams to go and do this thing without the authority to actually fix the problems on an ongoing basis, night shift, et cetera, et cetera. A huge other effect of this is that diversity and inclusion in SRE, particularly if you're a caregiver, therefore suffers because being deliberately placed in a situation which interferes with your ability to give that care just creates conflict with your family. And that's even before we get to kind of academic examinations, not just of the generic case of people working under stressful situations, which is really bad, but also academic assessments of on-call impact. So, for example, quote, 26% from a study in the Social Science Research Network, 26% of employees with a regular or on-call irregular or on-call schedules report often experiencing work-family conflicts compared to 19% of rotating or split-shift workers. It's actually pretty bad. Another recently published research in ergonomics says a group of about 169 male on-call workers, technicians, etc., investigates the connection between high levels of work fatigue and the need for recovery. And it turns out that even the threat of being called, even if no page actually arrives, puts you in such a physiological state that there is measurable impact. And there's serious evidence in the book Why We Sleep by Matthew Walker, suggesting that on-call work, or broadly speaking, sleep deprivation as a function of your work, lowers life expectancy. So think about that next time we're talking about time off in lieu. Now, next. Yeah, and there's a summary of other papers in the space, which I can, broadly speaking, summarize as stress is bad. Okay, fine. But actually, never mind those kind of theoretical approaches, but the experience of doing on-call on a day-to-day basis is also terrible. Not every team looks after their monitoring and alerting. So an on-call engineer on a given shift is often assailed by noisy alerts which are mainly or wholly unactionable, monitoring which doesn't catch actual outages and actual users that do, poor or non-existent documentation, unreachable colleagues, blame-laden reactions when things inevitably go wrong, complete lack of training. There's essentially no upside to practitioners for doing this, which is pretty awesome. So, to summarize, as a species, we don't like doing on-call. We're not very good at it. It's actively harmful for us, and it can be often be one of the most unpleasant experiences, professional experiences that you have. It's like, what the hell? Do we have solutions? Well, we have things we can do. We can make the existing situation better, or we can try an entirely different approach. So let's try and make the existing situation better because I'm an incrementalist. No, actually, I'm not. Anyway, training. We could improve training. Part of the problem with training is that there's actually no good academic context for it to happen in, no good on-call academic context. So you can't really assume that the new grad out of UCD or Stanford or whatever knows about on-call, arguably correctly. So people new to the sector often come with a bunch of assumptions which are not true, and they have those assumptions undermined in the white heat of an on-call situation. So actually, there's loads of things we can do here. There are multiple venues where training is available. There are multiple places where this is discussed. There are commercial providers doing it. PagerDuty training materials are great. Hugely possible to improve here. It's just that we would need to start talking about on-call in a more open way as an industry and be able to put this material in a way that, in particular, new grads or other folks new to the sector in some way could benefit from. Prioritization. So this is a huge one. Prioritization means prioritizing the fixes in the product, infrastructure, etc., but particularly in the product or service team that would enable more reliable behavior. The largest part of this, of course, is actually wanting to improve, and that's a serious problem because in many cases, not in all cases, it is firmly in the domain of culture, as Cindy Sridharan has pointed out, somewhat controversially but not unfairly. We need to be able to make the fundamental argument time and time again in a winning way that prioritizing reliability matters. We all in the room believe that, or well, maybe some of us don't, in which case I'll talk to you later. But the folks in the product team don't necessarily understand that. They're busy chasing product market fit. They don't necessarily understand that a more perfectly operable piece of software helps you to chase product market fit more effectively. And not all of the business owners understand this, and so on. So we have to fix the incentive situation, which is actually partially the promise of the SRE model. Accommodations. We have to make better accommodations for people. We have to have better standardized compensation models that are industry-wide, so you know about them in advance, and companies can pick the ones which are best for them. We need to have flexible schedules, particularly for the caregivers. We need to be able to facilitate recovery time. Here in the socialist paradise of Europe, where the European Working Time Directive shields us all from terribleness, what we need to do is we need to have the ability to shield workers from the overlap between their on-call difficulties and their day job, because they're often expected to soak up both kind of arbitrarily, and it turns out humans are really bad at that. And also, as a culture, we also need to fix the exclusion backlash that you get when you say, actually, you know, I got a new kid. I don't think I can do the whole paged arbitrarily. Oh, wait, hang on, I'm getting paged arbitrarily all the time, except by my baby. So I don't think I can do both of those at the same time and the day job. Like, that's not going to work. So we need some way to fix that as well. And on-the-job performance, which actually I think, like, it's much less important than all of the structural features. Like, latent structure is master of obvious structure in many ways, as Heraclitus apparently once said. So we can improve the on-call performance by just on-the-job performance by using cognitive hacks of various kinds to try and jolt us out of that kind of fight-or-flight reflex where adrenaline floods our system and we're narrowly focused on one thing, and our bodies undergo this terrible set of chemicals floating around because we're under stress. A whole bunch of these are possible. One specific one I'd like to call out is pair on call, primary and secondary, where you're working with somebody, and even just the simple act of somebody else being in the same room or on the other end of a IM or Skype or whatever connection, that can actually be physiologically useful for us. And drills, just doing it again and again and again until one part of your brain, one layer of your subconscious is aware that this kind of stuff is going to happen again and again. But actually, screw all that. Goodbye to the incremental improvements. What we do need to do to fundamentally change this situation, okay? So, of course, this depends on how you characterize the problem. So recall the central conflict at the heart of managing software systems. We know they're deterministic, yet they don't really behave like that, or at least we think they don't behave like that. They continually surprise us, I think is probably the right way to put this. Question is, how does the unreliability arise? What is the source of that unreliability? There's a survey in the workbook which says that configuration and binary pushes together account for 70%, almost 70% of outstanding outages, of outages in general. And a failure in the development process is about 62%, involved in 62% of root causes, and complex system behaviors only in 17% of them. So actually, that suggests we can make a lot of progress here. So I'm going to introduce two positions we could take: strong anti-on-call and a weak anti-on-call. In strong anti-on-call, what we're saying is, actually, if we stop all of the sources of outages, if we have a perfectly framed development process, if we perfectly control binary and config pushes, and all of that, eliminate the sources of the bad behavior will disappear. Now, as discussed before, the maddening thing about a lot of these outages is that so many of them are actually preventable. So many of the things that we get paged for are completely well known and understood, etc. So the strong anti-on-call position essentially involves preventing each of the sources of error in that table. Now, weak anti-on-call. Weak anti-on-call is actually, maybe you don't agree the strong case is entirely practical. We can't eliminate all of these causes. What we need to do is to make the system more resilient in very narrow ways and safely composable ways, that if all kinds of things go wrong, we have various layers of insulation, and isolation. And so in this view of the world, you may well believe that software is deterministic, We are convinced we're never able to react safely or react successfully and programmatically to unknown unknowns. And so what we'll do is, we won't eliminate emergency medicine by replacing it with war medicine. Instead, what we're doing is we're implementing driverless trains. We're implementing a system where we've one or like a small handful of responses to things going crazy. We'll stop the train. Maybe we'll stop the system. Or in other ways, we will partition the problem so that we can get to it later, and so we don't need to do emergency medicine. Again, it's that the strange thing is this position actually looks a little bit like the previous position in the sense that the work you have to do in order to accomplish it, which is really strongly resilient pieces of software, well-defined subcomponents running in well-understood ways, is actually the same thing you have to do. So the details of safe failure vary so much from business domain to business domain, we can't go into them here, and I'm out of time anyway. But the key principle is that the work performed should admit of partitioning, so you can fail safely across a larger number of partitions. Or maybe we could do both. Like, the industry needs to put more effort into making more resilient subcomponents. We're actually kind of doing that today with Cassandra and Kafka and all these other wonderful pieces of software we pull off the shelf. But the way that we pull them off the shelf and the way that we compose them doesn't necessarily make for a safe combination. Excellent. And AWS actually has some components, if I understand it correctly, which have been formally proved correct. So they have a way more safer guarantee of behaving in well-understood ways over time. So this is not actually hugely new as an approach. We just have to put effort into it. I will sing until the miracle comes. So in order to get rid of the scourge of on-call, emergency medicine on-call in the industry, we'll need an industry-wide effort, since what we're proposing is collaboration across a wide range of companies on components like this. The benefits would be incalculable if we did it. We'd have an industry-wide set of architectures so stable they could be taught in schools. We'd have a consistent approach to layering business logic. We'd have a more welcoming environment for caregivers and minorities. We'd have a set of methodically applied best practices and consistent data processing across companies. Never mind within teams in the same company, never mind within individuals in the same team. It sounds impossible, but actually, ultimately, it's a question of convergence. And we have in the past, as a species, converged on other things, right? So we converged on VHS, for example. We converged on the x86 instruction set. And we converged on English. All of those are really weird. There's surely more. But now the task is to push for this, because it is of benefit to everyone, even if it's only us right now who can truly see the extent of the benefit to come. Thank you very much.